Okay, today we do experiment, teacher.
Yes, lah.
Okay.
I don't know what we're doing. It looks complicated.
Ayo, so many retort stand.
Okay, let's read the instructions. So today's experiment, you're going to investigate oscillation of mass. What's the mass? Oh, okay. That thing. What do you think? What? Wow,
Yeah,
so many.
there.
Oh, mass. Oh. This one got plasticine one.
Yeah, no. Hey, we can take out the plasticine. Can we take out the plasticine?
Don't know, let assistant say, not to take. Got you remember she got say
I wasn't paying attention when the teacher give instruction.
Aiyo. Okay lah, we just leave like that. Okay.
Aiyo. Hey, let's see next door what they do.
After they wrong, then how?
Aiyo, better don't take out. Don't simply take things out.
Okay, don't take out. Okay, we looks a bit funny, but okay, we'll leave it there. So that's our mass. Then what
We need to
see the instruction and
we need to read the instruction.
Okay, we do step by step. Got two stand
we follow. I think we just put like that first.
Okay. So on the fast forward, we'll try to set up something to follow the picture.
Okay.
Don't know leh, you try and read and see how to do.
Aiyo,
see.
This teacher never give me answer one.
Hang mask M from the then hang
from the loop
From the loop
Okay.
I think it say loop, right?
It says string loop it looks like a string loop, so I shall assume.
Okay.
Do we need this?
How I think wrong already, teacher.
GG.
wrong liao.
GG, we need this one to be higher. If not, where we're going to hang the spring?
Oh, sorry. Wrong liao. This one. You see the the string is terbalik or like that?
Like that
Oh, okay. String can drop down.
Got the kiap to kiap.
Oh, got kiap,
Kiap.
Okay. Should be okay. Okay lah, you tie the ding dong there.
Wait, isn't this here? Oh, tie this one inside.
Oh, wrong liao. Okay.
This is what happens when we confusion. Do we put like this?
Don't know. You see the picture how?
Oh, the scale is front facing, so put like this.
Okay, we try like that.
Because
so, bounce like this.
Because if put like that, then can bounce like that.
Yeah.
You put like that, won't bounce.
Then the ruler bend already, you're reading wrong.
Oh, never mind. ECF
You and the ECF.
Yeah.
Then the other one?
But I heard my lecturer say now no ECF already. So sad.
So wrong already.
Dishonor. Can pull down a bit. I feel that we need to extend the spring.
Oh, the spring not even stretched at all. Cannot down some more. Then?
Okay, let's read.
Okay. Oh, you cannot simply do experiment without reading instruction. Okay, let's read.
Hang mass from the spring loop near the sorry. Hang mass from the spring loop near the end of the meter rule.
Okay, we hang.
Hang. Don't hang gay can already. Just hang the mass.
A bit. Okay, hang.
Okay. Ensure that the meter rule is pushing up against the rod of clamp A at approximately the 24 cm mark.
What is rod of clamp A?
Aiyo, this happened when you never read.
This one
Rod of clamp A is the other retort stand.
This one Okay. Then
But here have to kiap meh? Is this a rod? Or the rod is the one at the back? Maybe.
Like this, then how to? Cannot even. Okay, wrong liao.
Cannot oscillate.
How to oscillate? I oscillate the whole thing like this, then how? Cannot lah.
I'm pretty sure my graph will not be straight.
Wrong liao.
We are very inclusive here, but graph has to be straight.
Rod. This is rod. This metal here.
Oh,
this is clamp.
This is rod.
Okay, now correct. Then for on top.
Rod.
Below, sorry.
Below on top.
Ruler is below the rod. Okay, follow picture lah.
I highlight first, because sometimes I a bit blind, cannot see the picture.
Teacher, exam can bring highlighter one
Okay, sorry, undo.
Cannot bring highlighter to exam.
Yeah, sorry. Never mind. I will use.
A bit too low.
Okay, just want to hit myself in the face. Okay, this one is the metal rod.
I think it's correct.
Yeah, because if you look here, the rod must be above the ruler. And then they say what, 24 cm mark. So is this 24? This 24. Oh. Or is this 24?
I think 24 on the ruler. Okay lah, I'm going to find 24. 24 is somewhere.
Pushing up against the
Here.
rock. Okay, 20. Oh, 24. Okay, okay.
Hey, your mask drop off already.
Oh, sorry.
Hey, the mask drop off, you tie a bit lah.
I tie. Oh, yeah.
Means you put loop around the.
I loop the loop.
Loop a few times lah. Like you tie around there. If not, your mask keep dropping off, then how?
Like my hopes, no. My hope for a good result. My marks all keep dropping.
Okay, okay.
Paper 2 very hard. This Ms Lee set difficult paper.
Okay.
Okay, so this one is at the 24 cm mark.
Oh!
Right?
Now can move now.
Right. I always scared it hit me in the face.
Okay, 24
That will make a very nice
cm
blooper.
mark.
25 cm mark. The distance between the rod and clamp A and the string, attached the string is D. So where to where is D, Ms Ellie?
D is the rod here until the string. So here, lor. This is D. So how to measure? No more ruler or how?
Teacher, I need another ruler. Oh no,
Not
wait,
simply
cannot ask.
exam time lah.
Okay, so maybe we can read from this scale, lor.
Oh, good idea. So if this is 24, this one I hope is vertical. Does it look
Yeah.
vertical to you? I think
Yeah,
it's vertical.
but actually now we're going to break the fourth wall. When you are doing the experiment, you don't face the setup to the outside, okay? You face the setup to yourself.
This
You're
is
facing
setup,
it this way
yeah.
so you can see.
So you can see the thing. Yeah. Okay. Hey, this ruler keep on falling down like that.
Maybe we need to loop the ruler also.
Like the thing.
Like this
loop
one.
lah, loop lah.
Aiyo, so many loop.
How to loop? Wait, I tie a loop first.
So good. So loopy.
Then the ruler can stand up straight.
Very nice. Very nice. Okay.
Can oscillate or not? Try first. Oh, can already.
Can as long as this one doesn't. But then we need to add mass later.
No lah, this one different experiment.
Oh,
one.
sorry.
Okay, wrong apparatus.
Don't touch your friend's apparatus.
Okay, now can now.
The distance between, okay, adjust the position of the stand holding the spring, show that D is approximately 30 cm. 有没有? Got not?
This one is 20. Wow, wrong until so far. 24. So if this is 24, what should this one be?
54?
Correct. Good.
Oh, I can maths.
Very clever.
I can maths. Too many cameras to look at.
Aiya, your thing is too far away lah, cannot lah. You put nearer a bit. This one you see not straight already. They say string must be vertical. You see the thing there.
Okay.
String must be vertical. Okay. Still got problem.
Yes, what's
Does this look straight to you? I don't know. I think too near.
maybe need to let go a bit.
Okay. Like that.
But this one extends so much. Never mind lah.
After it break then how? The spring if overstretched then become what you call that spoil already.
Some deformation, plastic deformation.
The lab assistant also say don't overstretch, right? Okay lah. So we make sure it doesn't overstretch. Okay, what next?
Adjust the height of the clamps until the rule is horizontal.
Horizontal.
Using my magic laser eye, it looks horizontal.
Sure or not? I think a bit tilted leh. Here must up a bit. Sorry lah, I want the best data, okay? Other wrong already, then later, I don't know what happens.
Then after my graph, no, the best fit line not best.
Oh, the thing very long, I also hit the table. How
Can we shorten this loop?
Cannot cut You cut already after Miss Vanny scold you. You say, why you cut the strings here? I have to tie again.
Retie?
You do something. Can oscillate, right? Can oscillate, right? Looks okay to you? Okay.
Yes, the ruler is nodding.
So ruler is horizontal. Okay, I think we set up correct now. Just now we got wrong, cannot oscillate. Now okay already. Okay. Now what next?
Next. Ensure the spring is vertical. Okay, can. Move, measure, and record D. Oh.
D, just now what? 20.
Just now our reading. Okay, I trust my lab partner.
20. Wait, move already. 24. And then the other side on the string is what? 54. So your D is what?
So 54.0 minus 24.0, which will be 30.0 cm. I tell you, people always forget to write the 0.0 cm. Dishonor. Next.
Okay, then distance between A and the Wow, Miss, what does this mean? My brain hang already.
Rod of clamp A, which is the red dot that I draw just now,
Here.
and the string supporting M.
Oh, this one now.
But never mind. See, they label.
Oh, yeah.
Miss, they label.
Aiyo, they give picture, I never look properly also, then I don't see the thing.
Aiyo. So here.
So that was
here.
24.
So this one was 24.0. And this point here is 54.0. So now we need to read this point. Lor.
99, is it?
99 ah.
No wonder all the numbers so weird. 24, 99.
Conspiracy. Illuminati.
Okay.
99.0 minus 20. Ms Ellie, do you know why I write like this?
Don't know.
Instead of writing the actual working.
What do you mean actual working?
Like just, sorry, not actual working. Like instead of just writing the final answer.
Why?
Because if I don't write like this, if I want to double check if there's an error, I can find the error easily. Maybe I didn't sleep and then this 24 I write 14. It's easier to find your errors if you write your working.
Okay. So 75 lah from this end all the way until this end. Okay, can already lor.
Okay. Pull M down through a short distance. How short is short?
Well, the miss just now, they say don't pull too much, otherwise your spring will
spoil.
Then after the thing fall off, then
Can I
it's come out
sabotage
again.
my table partner?
No, cannot.
Okay.
After later they scold you.
Okay.
You pull and see.
Release so that it oscillates. Determine the period of this oscillation. Can I just measure one oscillation? Because I'm a busy person.
Then if your human reaction time is so big, then how you blur, you morning, you last night never sleep.
Yeah, then my percentage uncertainty will be very big. So we have to measure repeated oscillation. At least 10 I think. It's a nice number.
Okay lah, 10 easier to divide later.
Yeah. So we will measure 10 oscillation using a
Stopwatch.
10 Okay.
Stopwatch.
So Miss, how?
You just click lor, click.
But you see normally we need to observe the oscillation so that we have a rough sense of where it stops. Then we start the stopwatch. So are you measuring?
We will measure. Okay, we slowly measure.
Okay.
10 times.
So about 13 T1, 13.63 seconds. Can
Can lah.
Okay. Do I repeat?
I think better lah, cause maybe just now you first time do, so you're a bit slow.
Okay.
I don't know when I do this in the morning, my reaction is a bit slow lah.
Yeah.
Haven't
So
wake up
we
yet.
repeat again 10 T2. Let's say. Can I copy your answer?
Can lah. Okay, let's say you already do
Basically,
10
we did the
T2.
experiment before. So 6.
No, actually she never do. I do only.
Yeah, I copy her answer.
She's the lab partner that don't do one. Okay. Next one, 10 T2, so you get that one.
Then 10 T3 will be, let's say, 13.
13 point. This one?
This one Okay.
69
Can Then you find the average one.
Okay lah.
Which because our range is symmetrical our average is just 1.366.
Okay. All this working for 1 mark. Oh my goodness.
It's okay, Miss. I made a careless mistake in paper 2. I need that 1 mark.
Okay. Now what are we changing?
Without moving the stance, so we cannot change D right? Slide the rule horizontally through the loop so that D remains constant and S changes.
So cannot move the stand. Slide the rule through the loop. Which loop got 2 loop You see the picture up there? Come, I scroll for you. Just now. There got loop there on the middle loop on the right. How I know which one to slide?
Got one loop here and then another loop here. They say keep D constant and then you change S. So I'm thinking that we can move the ruler.
Probably true that. Actually this one Pi in the ruler already cannot move.
Yeah,
eh?
so this one
Okay,
there's
okay.
cannot move. So you have to move that one. But
Move
I
where?
think first we need to determine what is the largest possible value and the smallest possible value for S.
Okay. So I just
S
move all the way
changes.
lah. See
You
can
move
move
all
or
the
not.
way. S. Oh, but
I can fall down one. Like this Cannot already. The spring I think going to break.
okay.
Cannot. This one very dangerous eh.
So maybe move it.
Maybe not so far. We're trying to find the limit of
Yeah,
this thing.
find the range.
Can this one? The spring. Okay lah. I think that one have to put off the table, but never mind lah.
Do I need to loop again?
Can loop.
Should I shorten the loop?
Try the loop.
Triple loop.
Loop so many times.
How many readings should we take?
You got see them right there. How many readings? I
They
don't
say
know.
6 ma. But since you already do that.
Ah, got say 6 meh? Wait, let me see. Double check. When in doubt, always double check.
Aiyo.
5 sets on. They only want 5 lah.
Oh, really?
Very rare. Usually they want 6.
Yeah, lor, normally they want 6. Wow, 執到eh. Less work. More marks.
The thing going to. Can.
Maybe that one should shorter.
Cannot leh. Unless we do like that. I scared the string.
Oh, I know.
How?
To rotate the whole setup. So because my students say that sometimes they just allow this to hang
Can.
off the table.
Can.
So you rotate the setup. But then you have to make sure that D doesn't change.
Never mind, we can check again. Like that now.
Yeah. Is it still inside the camera?
I scared the spring is going to break. I think cannot this one also. You let go, is it? After it fly away, I don't know. Oh, cannot. This one's sliding.
Okay.
Cannot.
Cannot.
So I think this one's still out of range. Cannot. Okay. We test another one. Where was it? 44? 44 minus 30.
10.
Are you sure 10 Your maths fly until where? Ayo.
14.
Cikgu.
14.
10. Nah. Why you go like that again? Oh, because we time many. Let go and see. Can liao.
Oh, okay.
Almost.
Success.
I need to double check the length again.
Yeah, which is 30.
This one is tilted. This one 14. Okay, can liao.
30?
30 yeah.
I mean, is D still 30?
Yeah?
Okay, wonderful. Let's continue.
One side 14, one side 44.
A is 14, correct?
Correct.
Yeah. This one is
44.
44. Okay.
Okay lah, so this one is okay lah, I can work. Then the other way leh, how far can we go? Maybe this way?
Short. Oh.
Hey, cannot even balance oh. And then fall down, then how everybody look at you lah? Huh? Make so much noise in the lab.
Then you just sorry.
That one cannot already. Here leh. Also cannot the ruler like. What
Must
is
the
this?
ruler be horizontal?
Yeah. So if I put this higher some more, you see what will happen. Can
Oh. Wow,
It's sliding a bit eh. Can like that.
can
I feel very. Can lah. So this one okay oh. Go further some more. This is what? 70, go to 74. Go to 79 lah. 79 just now we cannot.
75?
70. Don't want. Just now 99 after you get.
Oh, you want the 444?
Weird number.
Oh, Uncle Roger don't like 4. I'm like 4.
This one cannot already.
Because
you see.
99 minus 4 you get 5. So
Cannot.
Cannot.
No, they
Or
cannot.
you bring down the retort. Cannot because it's
No, you want the ruler to be horizontal, but then because the weight of
Okay.
the ruler is going to pull.
Yes. So you have to push it there a bit.
Okay. This is cannot. Out of range.
Yeah.
I think this will be our next bet. 69.
69. So we are choosing 4 and
Ready lah.
9s because when we subtract with 99, we get nice numbers. Get it?
Okay, now we're going to do magic. We're going to
Okay.
fast forward and we're going to take all the data one shot. Just move lah, okay? Slowly go and move. But now we know our limits roughly where they are.
So this is still 99.
So then 99.
Then the spring is at?
The spring is at 69.
Okay. And the rod A?
39. All the 9 and all the 4s.
Ah, so this is wait, here to here is D, and you can see D is fixed at 30 cm, right? So we kept D constant, and here to here is S. So on one end, S is 99 minus 14.
89, 85.
85 cm.
85. See, no calculator can do one, but the brain will hang a bit.
Yeah. Then this is S. Then the other range of S will be 60.
Somewhere there.
Yeah. So this is our range of values for S, 85 to 60 cm.
So if we chop out all the values in between the intervals of 5,
So we can get 5 reading.
Safe already lah.
Yeah.
Okay lah.
Okay.
So we now fast forward.
Wait, what do I hear first?
Oh, your T. Okay lah, we measure some T. Okay, we already measured.
We record S first.
Oh yes.
So we take the smallest value or the biggest value. Where are we going to start?
Don't know.
We start with this one Don't want to adjust already. Very
Okay,
lazy.
yeah.
So we take 60 So Ms Ellie, I think it's a good idea to draw this first. Just so that if let's say halfway you confuse you know how to adjust your S.
Like
Right.
this picture of the ruler.
This picture of the
Oh,
ruler.
can.
Yeah, especially if you are easily confused.
Can.
Yeah, before your morning coffee. Okay, so T,
Okay, 60.
60
Wait. 60. S equals 60.
Okay, so we did the experiment. Miss Ellie did the experiment already. And the period is this. Do we need to show the repeat? No need.
No need lah.
So wait, I'm just going to write 10T here as 11.23 seconds. Okay.
Okay, can lah.
Alright, next.
Now we have to draw the whole table. Now I already draw table for you. See, ET. My table missing anything? You just let me know lah.
Oh, unit
Oh yeah, unit.
What unit is this meter?
Meter. We do cm lah. Cm easier. Then meter got
55
a lot of-
meter.
Cannot. I think it's cm. Cannot meter.
Okay.
So we do cm lah.
So slash meter slash.
Cm.
Oh.
You say meter, you write cm. You see? Like that wrong liao lor.
Sorry
Heading no mark already. Okay.
Success.
So the answer is okay. So
second
just
point.
now with 55 cannot already out of. Oh yeah, 0.0. Why 0.0?
Because we need to measure to the precision of the meter rule. Smallest reading is 1 mm or 0.1 cm.
So if I don't put 0.0, it could be 55.1, 0.2,
Yes.
Oh, okay. So now the 55 out already, we cannot do.
So we cancel lor.
Can use correction tape I brought.
Cannot. Just cut like that.
Okay lah.
If you are the type that you want your cancelling to look nice, I would recommend that you cancel this way lah. Okay. 60 got right?
60 can.
All the way, but 90 don't have right?
95 was the problem one we couldn't get.
Yeah.
90 I think is okay.
90 okay
95 I think problem.
Yeah.
Just now we try the hand cannot.
Yeah.
So
you
let's
can
cancel that.
You can cancel this one out this way. Okay. You can also double line lah. But please, I know people who cancel this way which is not very nice. They cancel like this. Cannot see where my pen is.
Nah, I see something.
Okay. Don't cancel like this
Why cannot? Okay lah. Okay lah. Don't lah. Very messy. Okay.
Very messy. Don't do it. Okay.
Okay, so we got a whole range. I think we are set.
Okay.
So let's say we already measured.
The readings.
We did 2 trials there. You see got 10T1 and 10T2. Then you can find
Because
average.
we are the overachieving Asians.
Usually for timing stuff, a lot of uncertainty, right? So you take more reading and then you average lor. Then that way if got some random differences, at least you have an average. So this one, yes, you can take average.
Mm.
Actually, how we know correct or not? We do. Is there a way to know if your trend is correct?
Hey, we should plot the graph lor.
But then very 麻烦 eh. Maybe we try to, what do you call that? Calculate the t-square line by line. Then you can check SF also.
Oh.
Pause. We go back to 60 and see.
Okay, okay.
So 10T1, 10T2, average become what?
Average become 10.60.
How many SF to put?
This 10.62 and 10.57 is 4SF. So this one I just want to stick to 4SF. Because 5SF is just too many numbers.
Okay. Then divide by 10.
1.06.
Also 4SF or?
Also 4SF. T
Square already.
1.123, which is also 4SF.
So actually this way we write row by row, you can easily check your SF for every trail of calculation. Okay lor. Okay, pause see we calculate so many settings already, right? How to check the trend? Is the data good or not?
I think because we made a very wise decision such that our gap is always the same. You plus 5 here. So we can check whether the intervals also are the same for t-square. What do you think?
You mean like plus 0.2, plus 0.2, plus 0.2?
Just make sure the intervals are about the same. So you subtract here. Because we gap here the same. But
check and see.
But if we didn't gap, don't calculate. If we didn't gap the same,
calculator.
I go take calculator.
Come, I draw.
But if we didn't gap the same, then cannot lor.
Let's see. So if the gap is the same, then here to here will be, what's a roughly difference? 0.2. Here to here there's a gap of roughly 0.3. Actually a little bit less, 0.2 something. Here to here a gap of roughly 0.2 something or 0.1. All about 0.2, so looks okay.
Okay, well done. Got 5 already, can stop here.
Actually can already. Wait. But if our range is not big enough, then
Then they take away our marks, right?
Since we still got time, right? We still got time. Take lah. Okay, let's continue to take.
Okay. Okay.
Done liao lor.
Done liao.
We shortcut a bit, if not have to one by one adjust.
Yeah.
If you are clever enough, you fake your data also okay lah, but you fake wrong, everything wrong liao lor. Decimal SF all this. So anyway, since we have time, we went the full range of a lot of data point. How many? 1, 2, 3, 4, 5, 6, 7. Okay
Okay, can plot graph already, right?
Okay, so what's next? Usually plot graph.
We plot
Okay,
graph.
okay. So dun.
Wow,
plot already.
magic. Okay.
So
Yes.
the best way to do is, why don't we just mark this graph? We don't have the mark scheme during exam, but we can, if you are familiar enough, you can tell what to look out for to check your own work, right?
Axis.
Axis
Got label.
got S/cm some more.
Very good.
In intervals of 5 cm, 5 cm, 5 cm.
In intervals of 0.1 for the vertical axis is okay. Corner plots only.
I made sure corner plot, but I don't know why the scan come out, my line become dotted. Never mind.
Tech problem.
Okay lah.
Okay lah.
Axis. What else? Check for axis. Scale.
Scale okay.
Scale okay.
Graph big enough. Got 7 points. Very nice.
What else you see on the right side there? Plotting of points. All observation must be plotted. So just now we got 7. We must plot all 7.
You must plot 7. If you only want to plot 5, you have to cross out whichever you don't want from the table.
Oh, so like that. Oh, we can throw away more anomalies. Okay.
Correct.
But it looks okay lah. My
it looks
data
fine. It looks fine. It looks perfect.
What else? Diameter. Okay, must be small.
So the plot cannot be too big. Right. Is it small enough?
I think got 1 point maybe a bit too big.
This one,
Yellow.
Oh. This one depends on the mercy of the examiner.
Okay lah.
You look like a lucky person.
Okay. Thank you.
But what happened here?
I don't know. I ran out of time, then my eraser, I don't know, roll until where you cannot rub off. So I don't know why. Okay lah, never mind. I will rub off. Okay, after this I go and rub off.
Okay.
Quality. All points on the grid. Yeah, we already did that.
Plus minus 2.5 cm on the x-axis. 2.5 cm.
2.5 is very
1
small.
cm.
2 box only.
No 2.5 cm is 5 box based on the scale.
Oh, yeah. Okay, that's a very big range.
Like
they
1
allow.
cm. Oh, the point is good. Even the furthest point is only 3 small boxes. Okay.
No problem.
Yes, no problem. So, this is 1 mark, full mark. Yay!
So if you do this, or you're familiar with the mark scale enough, you can pretty much memorize what to look out for already, no?
Yeah.
Okay,
Line of
last
best fit.
one.
Let's see. There are 3 points above the line and 2 points below the line. 3 actually. This point is also below the line.
I thought it's passing through the line.
It doesn't matter because it still looks balanced.
Okay
Like
lah.
this is passing through. But it's okay. It's balanced. It's
Okay
good.
lah, okay.
Wonderful.
No anomalies. Kink line. I know it.
Yeah, this is a kink line.
But that's the gradient.
Yeah, that's the gradient.
Okay. You need to go up, find gradient.
Oh, find gradient.
I show my working
Here.
but I have to write up there also.
Yeah,
right?
but please write here you're working on. If you know right, then it's a 0.
I think I see some friend never write. They just come out a gradient number. I don't know come from where.
Oh, wow. So then if you look at the actual mark scheme, we will need to make sure that you have the hypotenuse of the triangle large enough. The method must be correct. Please use the y-axis over the x-axis. Not this way. Read off must be accurate. Sign of gradient must match the graph. So
Positive.
Yeah, positive gradient. So what the examiner will do is they will zoom in and check this reading. So my suggestion is never take this and put here. Does that make sense?
Huh? What do you mean take this and put here?
Your triangle, your coordinates should not be, the coordinates of your gradient should be on the line but not a plot.
So then very 麻烦 oh.
In case you plot wrongly,
Oh. Then if you plot wrong, you go and use that as your gradient calculation.
then gradient all wrong.
Okay.
Yeah, so be safe, use the line.
Use a plot on the line that is not your data.
Yes, that is not your data. Do not use data values.
Okay.
Okay?
The writing, I guess we just write in the box.
Oh.
You see, I try something new. I always confuse the gradient units. So when I calculation down there, I also write my S square and then the CM there so that they can see. Okay one, right? If I write there.
Can.
Then I can know. Because now I confuse.
Yeah.
Am I in meter or CM or
always,
what
I
unit?
always suggest that people start writing units here. And then y-intercept will take the unit of
Okay.
y-axis.
Can lah.
So the y-intercept, because we didn't start from 0, 0, this is false origin. So we have to use y equal to mx plus c.
Must show working also this one.
Yes. If not, I cannot check this. We cannot check whether is a correct read off from a point. We cannot check whether the student substituted correctly.
Okay lor.
Yeah. So the examiner has to be able to check this. You can do all this in your head, you're very smart, but examiner cannot read your mind.
Okay. Last question.
Last one.
How many SF to put? I also always confused.
You mean
Gradient,
like
how
this
many SF? Intercept, how many SF? I do correct or not, miss? You check and see.
Is this a trap?
I don't know. I just do only mah. Aiyo, miss, you help me check lah, miss.
Aiyo. So this one, the smallest possible reading is 0.5. So the x-axis should be 3SF lah.
Correct,
or read to the nearest
59.5.
0.5. Yes. Then this one can be read to 2 decimal point. So this is also okay. So 3SF, meaning your gradient should also be 3SF. Because you can see this one is 3SF. This is 3SF. Everybody is this 3? Okay, can be 3
4,
or
7,
4
6,
SF.
7. But then you can round later, I guess.
Can be 3 or 4 SF.
Okay.
Okay, and also you notice that we have changed the CM. and converted this.
Yeah, because I was scared like maybe I need it in meter later, so I change now lah.
Yeah lah. So if let's say you don't know how to change here to here, because you notice the compulsion is to divide this by 100, but actually you need to multiply by 100.
Because CM -1 no?
Yeah, CM -1. So if you're scared you have that kind of error, right, then your conversion should happen when things, the earlier your conversion happened, the less the confusion would be. So you can do something like this. This is CM, right? Immediately times 10 to the -2.
Oh, okay.
So then you no longer confusion, no? You give the calculator your confusion. Okay.
So it's
That's
helpful lah, either way, to write the units in your gradient working itself. So
Yes.
you make sure you don't confuse. Okay.
Yes.
Okay, very good.
Very good. Shall we continue?
Last part.
Okay. So
Quantities T square PS plus
so this
Q.
is your y-axis, and this is your x-axis. So I can say P is gradient.
Okay lor. I'll just write only like that.
And
2
Q
marks
is
already.
y-intercept.
Okay.
No, I haven't finished yet.
Oh, okay.
So I need to copy my gradient value. Copy. 4.767.
Okay, so we write lah.
Can write red pen. Exam don't write red pen.
Can lah, you just write red color.
4.767.
767. S square meter -1, correct?
And then your y-intercept was
Negative something what was it?
negative 1.74. So a y-intercept can take 3SF because the smallest reading on the y-intercept is 3SF. Generally, if you don't want to think too much, 3SF is always very safe to keep. And copy over lor.
So I think this one, if you look on the right side, 1 mark is for your value if correct, then 1 mark is for unit or. So if either one wrong already, you lost a mark already.
Yes, so if you didn't write units, you will lose 1 mark. And also at the same time, if you if you didn't write this, I can pretend I don't know how you get 4.767.
So must show working also lor.
Yeah lah, because if you don't write this, I can be very mean. Where you get 4.67, I also don't know. But if you declare like this, clear, then I have no grounds to doubt where you got your 4.767. So you might show all your working.
Okay, I think that's it. We are done.
Question 1. So we get 20 out of 20.
I think so. Maybe if you minus off the point just now, then don't have lah. But I think okay I think okay.
Yes.
Go and check the range. Oh, we forgot to check the range. Just now we try test the range, we forgot to see. On the right side. What's the range? At least, wow, very strict this one.
Less than 70 and at least one value greater than equal to 85. Oh,
Oh, toy.
so the range needed is 70 to
More than 85, I think.
more, but can be equal ma.
Oh, yeah. So okay lah, we are safe. Our range is big enough.
Yay.
Nothing much. 20 out of 20 leh. Just now almost do wrong in the experiment.
Yeah,
Kiap here, kiap there.
Yeah, almost hit ourselves on the face some more.
Okay,
Okay, experiment is done. We're going to move on to experiment 2.
shall we?
Okay.
Got time? Can lah.
Don't know.
Experiment 2 very fast one. Just ding dong ding dong.
Okay.
Okay, here is question 2. We have a spring. The same spring lah. Very annoying, right? Then we have to do what measure diameter so that's what you're trying to do lah.
How lah?
Okay, I don't know. No, I zoom in to see what you're doing. You continue doing lah.
So, it's very hard. Can I Karen this part? I write as sources of uncertainty.
Why don't you try put the ruler on top of the spring can You cannot
We're talking.
You cannot. Okay, never mind.
Oh.
Oh, how, what, where?
Like this. Can
Can the loop there very blocking
Oh, I just try our best Some more this ruler so long. Are you?
So it's good if you have your own 30 cm ruler.
Yes,
lah,
please
I
bring
guess.
your own 30 cm ruler. During actual exam cannot borrow.
Okay lah. So what's the reading? What you think?
Around 1.5, 1.6.
I can see
I
Can
don't
lah.
know, can see.
Can lah.
Can see.
Okay lah. So we write 1.6 lah.
Okay. Should we take multiple reading? Generally, it's
Actually-
for question 2, we take 2 readings.
Can lah. I mean, it's a static measurement. It's not moving around, but it should be roughly the same lah.
I think a bit paranoid already. Always I lose mark in this question because I didn't
Never take repeated reading.
reading.
That's why.
So the average is 1.55. I will put 1.6. Okay. Estimate the percentage uncertainty in your value of D.
What do you think?
I think I can use half the range, but then which is 0.05. But then I think I will take an estimate, so 1.6. In ideal circumstances, it's going to be 0.1, but this is less than ideal, as you can see, so maybe 0.2.
Yeah. 0.2?
Yeah.
Okay lah. Sounds about right.
So this is 12.5%. Normally, percentage uncertainty, we will write in 2SF.
If I write 3SF, will they minus? Or is it doesn't matter?
They didn't specify, but
Okay.
I don't like to take risk. Okay, next. So you can see from the mark scheme, the range is very big, but need to have unit.
Go unit 1.6 cm. Okay, can.
So you know right unit, then you GG now.
Okay.
So this one they didn't specify lah, but generally, it's up to you. Not up to you. 2SF is the general standard, but you want to write 3 also, you probably will not be penalized.
Okay.
Okay,
Sounds
so
good.
next, place a metal strip through the spring.
Oh, this one looks like knife like that. You see? You see? Too many camera liao. Cannot focus Nah. Metal strip. Okay, so place what
In the middle.
Now you do. I take camera for you.
Should be approximately 1.5 cm. So this, if this is, that means it's the whole spring already lah, right?
Got so long meh?
The spring is 1.6, so if you want to put it at 1.5,
So you have to cut it inside the spring.
so it's almost here, somewhere here. Good Lord, how?
How to measure? This is a very troublesome experiment.
Yeah, but we can do this. So new angle so that the camera can see. Right. Okay. So 1.5 is around here. Okay, this is about 1.6. Okay,
Okay lah, okay lah.
move on.
What next Measure record X. I just write lah.
Calculate the volume V inside the coil part of the spring below the. Oh my lord. What?
So must show working also volume.
I show substitution because if not I cannot. How do we check for this one? So you also always have to think of from the perspective of the examiner. In order to award you the mark, they should see this. So diameter is 1.6 cm.
If you are doing cm, okay lah.
Okay. Then x is also 1.6. Then divide by 4. Okay, so you can see the range is quite big lah, but you don't be too far away, okay?
Value of x to the nearest mm. Okay. In range 1.3 to 1.7. So it means if you're off, means you're really, really off already. Should be okay. This one should be okay.
Yep.
Okay. So you see the marking for V, it says correct calculation of V. Wow. So must calculate correctly now. If press wrong, then wrong now.
So 3.2, you see 2SF, if you want you put 3SF lor. 3.23 times 10 to the power of negative.
That one's in meters. I think you want meter or meter cube or cm cube
first.
Okay, cm cube.
If one later can convert.
Okay.
Clamp the metal strip so that it is horizontal with the loop.
Okay, so now I have to set up. Alright. So clamp the metal strip. Okay, this one you already do for me. Clamp where? Clamp here. Wow, how to clamp? Okay, so clamp. Hey, cannot be straight leh, it's a bit tilted. This one it's like got problem on this thing. Never mind, I try my best.
Yes.
Kind of clamped.
But
did I clamp it upside down? I feel like I did. Aiyo, then wrong liao lor, it's
wrong
very
the long loop, the longer one should be below.
So this one is the longer one, okay.
X should be below, based on the figure 2.2.
There we go.
Sometimes
Then
a mess.
Doing. Mess.
Mess,
Oh,
mess.
mess. Got 3 things. Need to put on.
Gently hang 300 gram. Make sure that the base is around 20 cm.
From above the bench.
Okay, so we're gonna measure this and pull down by 1 cm. 10 cycles. Record enough readings to determine the accurate value for time t taken for one complete cycle. Okay, pro tip, you see the 2 marks there? Confirm got repeat reading already.
So I have to do a few times.
I have to do 10t. Have to do, wow, this Ms Ellie do 20t.
You know, they say do at least 10 cycles, so I scared, oh, move very fast later, I cannot then.
Okay, so...
Okay, now so we ding dong ding dong. Where's the stopwatch?
Ding dong ding dong.
There.
Ding dong ding dong.
So I do my timer thing. I mean, you can take video, but make sure you have a way to see your timer or your video timer. So, hey. So displays and measure. Okay, so we wait. Hey, I got worry leh. What if I pull then my hand exert a force on the spring, then it will affect the T?
Oh, later we write at the confession page at the back of the experiment lor.
Okay.
Got force on release.
Oh. Okay, we do first. Hey. Okay, so we have taken readings, do 3 times. Each round is 20 oscillations, as you can see. So that means you find the average 20T, which is 12.07, and then we divide by 20, 20 oscillations. So average T will be, well, make sure you press calculator correctly. We got 0.6. Is that in range? You see on the right side was 0.1 to 1.0. Very nice. We are in range. Yay. Miss do correct.
Evidence of repeated measurement.
Got. Then we show that.
So clear.
20T.
Okay.
Now remove the mass from the spring. Okay.
Oh, so now it have to be 1 cm instead of 1.5, 1.6.
Okay, so we measure roughly. Come, I do this one for you.
Okay.
Just now you measure until so long, I wait until 1 cm is roughly here. Where's the knife? I lost the knife already. Sorry. Oh, it's so blur, I panic. During exam. Where's the knife? Teacher, this question too can ask for help one during.
Cannot.
They won't give one.
You just stay calm lah.
Okay.
It's
so,
somewhere.
1 cm, I guess. What did I measure? 1.1 roughly.
Okay.
On the ruler. 1.1 cm. Then we hang again, is it?
So repeat B and C. So basically, we measure a cycle again.
Okay lah, you calculate volume, I time. So you write your working, I will do the timer. Okay. Okay, so actually there's more reading. I did many times. 5 reading, but we lazy to write out. But you can take the average. Actually, if one of the reading looks very weird, you can just throw it away. If it looks very off from everything else. But anyway, so we got average 0.5097. Volume. Hey, this one is the just now they say got wrong.
Need to check whiteboard for announcement.
Just now they announced they say got wrong unit, must do correction. Okay, so it's actually meter.
Meter cube.
Meter cube.
Okay, so can be 2.212 cm cube or 2.212 times 10 to the power of negative 6 meter cube.
T is down there, 0.5097.
Uh-huh.
Is this correct?
Do we write the correct SF?
I don't know. 4 SF correct, right?
Well, based on all the time measurement is 4 SF, so this one 4 SF should be okay lor. Okay. But this one a bit like too many SF like that.
Never mind lah, we just...
So I'm just going to remember that Ms Lee will scold me.
Okay lah.
Why did I refer to myself as a third person? What is life?
I don't know. Now you see the mask scheme. Second value of T must be less than the first.
What was the first value again?
0.6 something.
0.35. Okay, very nice.
So it's lesser. Then correct, you get a mask scheme. That's how you check. Oftentimes they will always say this in mask scheme for question 2. Okay. Hey, just now I got problem. Just now when I try to pull the thing swing here, swing there, very hard to tell when the oscillation ends.
So shall we complain now? Right?
Later lah. You remember?
Wow.
But it's useful lah, because as you're doing the experiment, you think of problem or you got idea already.
You think of the problem as you do the experiment.
Okay. Oh, this one. Just calculate only. Okay. We will do very fast for you to see. Just plug in both of the values. Write on the calculation. Please don't press wrong calculator. And also keep an eye on the SF, what to write. So this is what we call two sets of values. Now we will use this later, two sets of values. Do one time. Repeat experiment, do again. And we will use these two sets of values to come to a conclusion later. Test a hypothesis. So let's calculate and see what we get.
They don't look the same.
Are they supposed to be the same? I mean, ideally...
They're supposed to.
Well, you see, if the relationship between T and V, K is a constant. So if constant should be the same, no matter how you change T or V.
Yeah.
It look very weird, why the number so big? Correct ah?
Oh, because you convert to meter already ma.
Oh, so if I do in cm -3 also okay lah. Right?
Can.
Okay lah, never mind.
Then this
We'll
one
continue.
will be 0.1206 s square cm -3.
Oh, I guess the masking doesn't care. Or you see the right side, they only look at your calculation, not necessarily
How
like
can
your
we check
value.
whether your calculation is correct or not? You need to show the working.
No show working loss mark liao lor.
Yeah, no. Justify the number of SF.
How to justify? Why we choose the SF?
Okay, what did we measure?
You mean the
To get
raw
K.
values
To get K, we measure T.
We measure time, stop what?
So T is 4 SF. Did we measure V? No.
No, we measure the spring.
D and X. So D and X using ruler is 2 SF. If you forget, you can always go back and check.
So I guess it's good to make a list of the raw values.
2SF. This 1.6 is 2 SF, 1.1 is 2 SF.
Maybe we write there D, X and T is our raw value, just at the side there. So we know. Because I saw a lot of friends also, they never say D, X and T. They just say V and T.
But you didn't measure V.
Okay, so how shall we justify? Let's write out the sentence. Mine is wrong. Don't see my one. I don't know how much. Oh yeah, V.
Hey, T has 4 significant figures. You can come in coquette, it's okay.
Just don't start singing.
Wow, if you start singing, I want it recorded. Follow the least SF, which is 2, or least SF plus 1. So we write too many SF.
I think too many.
Need to go back and change. So key K has 3 SF.
So this 1, 2, 1, 0, 0, 0.
Yeah, so this is 1, 2, 0, 0, 0, 0.
Not 1, 2, 1. The 6 round off already.
Oh yeah,
you see?
I feel kindergarten.
Round wrong already, then.
GG.
Then this one become 1, 1, 8, 0, 0, 0.
Means during exam, I cannot rub like that, lor.
You have to cancel, lor.
Cancel, you don't write so big,
See the mask scheme justification, you must say D, X, and T. Don't just say raw reading have 2 SF.
X.
Time.
Oh, T.
So you just say raw reading have 2 SF.
No.
Therefore, I do 2 or 3. Cannot. You must say what values. What are the raw values? Last one. Explain your result using the relationship. So for this one, all you need to do is, first step, calculate the percentage difference. Just now we say K should be the same, right? But they're not the same. Obviously, you see different numbers. So how different are they? So what you need to do is you take one value, rounded nicely, okay, minus the other value. Just take the bigger ones minus the small one. Divide by the average. So here we can see us write this. That will be your percentage difference in K value. How many percent are they different? You and your sibling, how many percent are you all different? Are you going to measure?
How to measure the similarity or difference?
I don't know. Ask the bio people, they'll come out with the, genetic difference. Never mind, that's bio already. Okay, 2.52%. So now we need to compare with something, right? So they're different. Is that because they're really different or because of some uncertainty now?
Oh, because just now when we measure, what's its name? When we measure D, the uncertainty is 13%. But then we measure a bunch of other stuff also, right? We measured D, we measured T. So I think the actual uncertainty of the experiment can be rounded up to 20%. Because we measured T, we measured X as well. So hampalang this one.
All put together will be more than your uncertainty in
because D is 13%. This one sure got something.
20%?
And this one also got something. So together maybe you have about 20%, right? So
need to calculate
No need estimate.
That was paper 2, right?
Because 1 mark child.
Okay 1 mark no need to calculate.
I don't want to work so hard.
Okay, so we just look at our D, round up to the nearest 10, 20, I don't know, 5%. And we say, since the percentage difference of K, how many percent? I mean, we calculate 2.52, but no need to write all 3 SF, right?
It's smaller.
It's smaller than...
Or less than.
Your uncertainty in the whole experiment, which was what? 20%. Okay, so if your difference is smaller than uncertainty, how do we conclude? Well, you can say that, therefore or hence, your results support the suggested relationship between T and V, T squared and V. So this sentence is pretty much a standard pattern already. You just memorize the sentence, plug in your percentage can already.
Or you find a lab partner who memorized and you just copy from her.
Exam cannot copy. So you memorize okay. Don't creative write out some kind of essay.
No.
Because you see on the mark scheme there, they say one sensible comment.
So we are sure that what we give you here is sensible. But if you write your own thing, whether it's sensible or not, then you leave your fate to the hands of an examiner that you don't know. Because you don't know who's going to mark your paper.
Okay lah.
Okay. My favorite part.
Okay, can we think of any ideas? What is the thought process behind this? I know we always see the mark scheme, but how do you think about it without peeking at the mark scheme? cannot see. You think?
Okay.
Cannot give in so fast. Don't go and find mark scheme.
So the first thing I'll write is 2 reading not enough to draw a valid conclusion.
That one every experiment.
But can I write 2 reading is not enough?
I think it must be more specific than that.
Yeah, no. So
2 readings. Okay, we fast forward your writing.
Yeah.
Okay. I think I got one friend last time, his whole last page all blank. I said, I wasted.
At least write one write this one.
These 2 answers can always write one. So you don't have enough reading. So what you do, you take more reading and don't say take average. Later you'll see the mark scheme wrong. So you take more reading and then you plot a graph. Never mind.
Plot a suitable graph. Don't just say take more reading. What are you going to do with your reading? Buy Toto. With the numbers.
Why Toto? Take more reading, or you can say compare values.
Okay, so what else did we do? We measured D, right? They got large percentage uncertainty. D is the diameter of the spring. Okay? So we can say that there's a large... 13% is quite big. Especially if you're measuring a static object. Large percentage uncertainty.
Must say Y one. Can I just say large percentage uncertainty?
In which measurement? You measure D, X, and T.
Okay, better say. Okay, so you must say, I guess we should add always what measurement we are measuring. Large percentage uncertainty in measuring what? D. I guess if you want to throw in the reason better. If can, right?
Yeah.
Sometimes mark scheme will be strict one. So I say due to, you give a reason.
Small value of D.
Oh, just now you say also the
meter rule.
The meter.
You can use a vernier caliper or a micro.
Oh, that's a suggestion.
Yeah.
How to improve.
Yeah. Or low precision of the instrument given.
And then the loop kind of block the middle when you try to put.
Yeah.
Many problem. This D. Okay, so we got the problem, percentage uncertainty, we have the measurement, D, and we have the solution in detail. So how to fix? Use vernier caliper though.
So the first problem is the D is too small. You can say use a spring with larger diameter. Please don't say just use a larger spring. Larger how? Which part larger?
I also don't know.
Okay, if your comment is the precision is too low, then you can say use a vernier caliper.
Micrometer can ah? Actually cannot eh.
Because when you use a micrometer, you need to squish, and then the shape will. When you squish using a micrometer, the shape will, the spring will change lah. You
Okay
know
lah,
what,
so
you know what I'm talking about.
Vernier lah, vernier.
Use a vernier caliper to measure D. Please be specific ah. If the examiner wants to be very strict, you just write use a vernier caliper, and you never tell me the vernier caliper used to do what. No marks.
Use a vernier. Okay. So to be safe, we want to be as detailed as possible.
Yeah. Means can I write number 2 use a spring with larger diameter, number 3 use a vernier caliper to measure D?
Isn't that the same problem?
Same problem. The solution will only have 1 mark.
So cannot. Okay
So
lah.
cannot.
So we try to find a different problem.
So we talk about D already. Can we talk about X?
They are part of the same thing though. No meh.
You put the X, you measure the.
Okay lah, we try and see how we write and see how. What was the problem just now you measure?
Okay, I think never mind since we don't know. We are not sure, then we don't
I'm not
talk
sure.
about it. Maybe we
Maybe
talk
it's
about
still
other
the
stuff.
same problem.
Because I think oscillation got a lot of things to talk about. Like
Key,
just now you say the thing swing here, swing there.
What is that called? Supposed to go up and down only, but then you go like that. Then very hard for my eye to see.
So what do we write?
What we call a plane of oscillation.
Okay, so the mass.
Many planes of oscillation. Maybe you can say that.
Okay.
Mass. I think I spoiled the spring now. Out of shape already leh. Must tell Miss Vanny sorry now.
Do not oscillate in a straight line. In one
Single
plane.
plane.
In a single plane.
So oscillate in single plane means supposed to go up and down. You go left and right, front and back.
How to improve?
I think no improvement or how Oh no. So what happened if can I just later I find another
way to improve but this one can keep
Oh, okay lor.
Okay then can I say it's difficult to start then the oscillation one normally we can say difficult to judge the start and stop. Okay.
Start and stop of the spring because it move up and down. Then we hard to see lor. Should we say mention T difficult to judge when the oscillations start and stop when you're measuring T.
Yep.
I think we should mention that also. Wow, okay, this one got a lot of problem on this experiment. I think got more. Just now the ruler also bend a bit. What else?
The metal strip can bend.
Oh, just now when I hang it is doing doing doing. So it's not just the oscillation of the strip, it's oscillation of the spring and the metal strip also oscillating. But never mind lah, we already got 4. So if exam I write 5, will they give me extra if one of them wrong? Let's say my number 2 wrong.
This one is up to the examiner.
So
so
okay
it's better if you choose the best 4.
Top 4 and then the not so sure one put later. Okay.
Causing what?
I don't know.
This bends under the weight, affecting the oscillation.
At least got say what it affect ma.
Yeah.
Say that. Okay lah. Okay. We almost done.
Okay, how to improve the...
Don't have improvement. You say put in the tube.
Oh, no. The one we can video and review frame by frame to find the period, to judge where the oscillation stops. And
Take video of experiment. Can.
This is so meta right now.
What is meta? Video experiment.
We are videoing ourselves talking about videoing the experiment.
Okay. Take video. Okay. I think we should mention also. Take video must mention what you are measuring. Of course, we already said that many times. But you must also say how you are measuring it. Say you're measuring time, right? How to measure time? You look at the thing bounce in the video. How you know how long it takes? I guess you have to mention also timer inside the video frame. I don't know. You just take the video, put the timer there, lor. Okay. Or you use the video timer, watch frame by frame also can lah. Okay.
Finally.
You forgot to mention measure T.
Oh.
After the examiner minus then how? Then that Mr. Ben always minus one. Everything. Last one. I'm stuck. What's the idea? What's another idea? Can we? Oh, just now I say got problem. Got force exerted on the spring. Is that
So use
considered?
Use a card gate.
Can consider that a problem? I think like not so much leh. Because the spring,
You pull down, then you let go.
I let go, then it's after that it's not affected already. Oh.
Can see answer.
You want to see answer, then you this one 0 already lah. You write some.
Use card gate lah.
Oh,
Yes,
I know.
Yes.
So the just now we say the metal strip can bend, right?
Ah.
That's because we kiap it from one side. What if there's two retorts stand to kiap like that?
Oh.
Then it won't bend like just.
Okay,
I don't know. I just try and see.
Yeah,
I see whether correct or not.
Clamp
The metal strip, both ends.
strip on both ends.
Let's say long. To prevent bending, I guess. No need lah, just say.
The spring in the middle.
Yeah.
Yeah.
We did suggest as number 5, but maybe it's correct. I don't know. Okay, let's check and see correct or not. Now you can check the answer.
Change color. Time to red pen.
Yeah. Okay, come.
This one should correct one.
Straight away, number 1 correct. Let's see. Parallax error indeed. Oh, first time I see parallax error.
Yeah, but then you
answer.
can't get that mark if you didn't mention because
Oh, so you must say because.
the loop is in the way.
So if the one we write, D is small, I guess okay also. I would accept it if I saw this now. D is small, so large percentage uncertainty.
V is not accurate because D is not internal diameter.
I guess that one's debatable, but okay, interesting. Didn't think of that.
So if D is not the internal diameter, then you need to measure internal diameter by minusing or subtracting the thickness of the wire.
I lost my wire already. The spring fly away already.
So you minus the thickness of this. Minus this one. Okay. So you notice that the swing side to side horizontal movement, more than one plane, there is no improvement.
Oh, so
saying it. I have to say it. Okay. So time is small, large uncertainty in T. Times are small, meh? Was it very small?
I mean, if you take one oscillation, it's quite fast lah.
Okay.
But I took 20.
10. Oh, you took 20.
20. Because I very scared it moves so fast. I cannot time properly.
Okay, lor. So use a bigger mass for improved timing. So video and review frame by frame. Okay, sure. Difficult to judge the start and end of oscillation.
Then we say that, correct?
Okay.
What's fiducial marker? The name sounds so fancy.
Fiducial marker is just
like my
like you
finger
mentioned,
put there
her
lah.
finger is a fiducial marker.
Okay.
Fancy pair, fancy. Metal strip bend or not horizontal.
It got
Use a stiffer strip or support strip at both ends. Or use a thicker strip. Okay, let's mark.
I think should be okay, most of it. One of it is not in the list lah. So
Record video, review frame by frame. Say.
Got.
Video with timer and view frame by frame. This one. Okay. So cannot credit both. You only get 1 mark for the same thing. Use a vernier caliper is okay. Metal strip will bend, okay. Difficult to judge where the oscillation start, okay. Different frame, okay. This one no need because I write 5 and I am a nice examiner because I mark myself. So
!aiyo! You !aiyo!
Okay lah.
Depends lah, your luck lah.
Yeah, if you write extra one, I don't think it really matters.
Put question mark there lah, so you don't know. Maybe. If they are accepting.
Yeah. Alright. Anything else that we should tell the students?
No, I think this is mostly it.
Yay, 20 out of 20.
19 out of 20 lah. 19 out. I don't know lah. Maybe. Very nice.
Okay.
Good job, teacher.
Oh, thanks. Good job, teacher. Okay.
So, yeah lah.
I think that's all. We'll see you in the next video. Right?
Yes. What's the next video? I also don't know.
Okay. Please review your mistake and check.
If you keep making the same wrong mistake, then
Look, the next time you do lab, it's going to be it already, okay?
ON20 liao lor.
Yeah.
Or ON21 or whatever lah.
Defer.
No lah, don't defer lah. Okay, so that's all for this paper 3.
Okay.
Go and review all your papers. Make sure you check through the mark scheme. All can hear, all you can find in OneNote already lah. So go look through. These two happen to be past year. So if you think they are hard, this is past year, you know. We didn't purposely make it hard for you, you know. It's past year.
But I think it's easier past years.
This one is a bit. MJ18 is some more 2 years ago only leh.
Yeah.
Some more they.
Yep.
So anyway, it's all past years. So that's all for today.
Okay. See you.
Bye bye.
Bye bye.